Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video will explain about the second subtopic under chapter 6, which is frames and machine. Okay, previously we already covered the trusses, where there are two methods, which is method of join and method of section. Okay, so for this frames and machine, what are the difference between truss and frame or machine is, under trusses, we focus on the two force member, where the two force member is include two forces at the end of the members, where we have two opposite forces with the same magnitude. For example, we have here member AB, and the two forces should be FAB and FAB. Okay, two forces but same magnitude in the same line of action. So that's the mean of two force member. As compared with frame or machine, at least one member is a multiple force member. Means that they are still using the two force member here and here, but this one is two force member. This one refer to the multi-force member, means that they are external loaded along the BC member, right? So ada additional forces or load applied on the members, right? So there are three forces in total. We have FBC here and FBC here plus 2000 Newton pointing downward. Okay, so in total we have three. So when there is more than two forces applied on that particular members, is considered as multiple force member. Okay, next we have frames. What is frames? Frames are a rigid wood structure, typically fully constrained, maintain their shape with or without external load. That's mean, for example, we have here the bicycle frame. So it is a rigid structure. There are no movement inside the frame, right? Should be no movement. Typically fully constrained. Okay, they attach to the tire, to the handle, and so on. And then it also maintain their shape with or without external load. If we sit on the bicycle, let's say we have a seat here, right? People sit on this. So either we apply the load or without applying the load, the shape of the frame is still remain the same, right? That's the meaning of the frame. And then for the next figure here, we have a traffic light frame structure here. Okay, so this referring to the frames also. Okay, it is a rigid structure, a fully constrained, and maintain their shape with or without external load. Okay, next, while for machine, a non-rigid structure means that include a movement inside the body, the structure which contain moving parts designed to transmit and alter the effects of forces. Means that whenever we apply the force, the structure are moving, right? Same goes to here. We apply force, push upward, and then the truck will rise up to pour everything inside the truck here for example. Okay, and then for this plier, we apply forces here, and then at the front area here will clamp the material, for example, right? So it involves non-rigid structure and contain moving parts. Whenever we apply the force, it will transmit or alter the effects. Okay, then working with frames and machine, so we have to do several assumptions to solve the problem. The first one, must have at least one multi-force member, right? In our structure, we should have at least one multi-force member. Can contain several number of two force member. So any number of two force members should be no problem, but at least one multi-force member should be there. Then kita consider under frame and machines. This is the first assumption. The second one is the external forces can be applied on the member. Okay, applied on the member here, not applying at the joint. Okay, at joint, same as previous one, trusses pun we have forces applied at the joint, right? Now we focus on the forces that applied on the member. Okay, this is the second condition. And the third one is all members are joined by pin connection. So we can assume that all the members, so we have members AB here, we have member BC. So between AB and BC, there is a pin join, pin connection. Assume all the joining between members are using pin connection. Okay, that's it. We have three assumptions that we need to focus in order to solve frame and machine kind of problem. So back to this slide. Review two force member. So a member or rigid body with only two force acting on it. So similar with the previous one, we know that the two force members should have same magnitude, same line of action, and opposite sense or opposite direction. So it can be either straight member like this, either tension or compression, and then we have also a shape like this, AB, but still the force is still the same, FAB, since the point is under the same line of action, the force direction is under the same line of action. And not to forget, we have to put there the opposite sign in the opposite direction. Same goes to this shape. Okay, L shape also contain the two force member, opposite side, in the same line of action.